Today we'll be covering the topic architecture patterns, and these architecture patterns are common microservices patterns, and I found this very useful uh, for answering system design queries because what actually happened is system design interview is an interview which is around 45 minutes interview, and in that interview you have to design a complete system, which is like design YouTube, design Twitter, design any very large scale system which could be Gmail, and becomes very difficult to complete all the design within 45 minutes because nowadays companies, they expect you to take care of scalability, availability, performance, security, also various best practices for monitoring and troubleshooting, and your architecture should be easy to develop. So there are so many qualities you have to take care. So it's always good to follow a pattern. Pattern is a set of best practice which you can apply, and these are proven set of best practices which have been working well in various systems. So these are the collection of best practices, and there is a book, so people who want to go through in very detail, there's a book with the same title, Microservices Architecture Patterns, and that book is from Manning Publication. But yes, like any other topic, technical topic, for example, design patterns, it's hard to understand them by reading books. It is easy to explain it if someone has an experience and we have a kind of a discussion around it. So that will be a good way to learn these patterns. So I have shared these list of patterns. Actually, there are 11 patterns. I will just try to put them all in one screen. There are more also, but these are the common patterns and the patterns which we will be discussing. So you see all the 11 patterns. Great. So the first thing is, most of the applications in the world are monolithic applications. Monolithic pattern, can anyone explain me what is a monolithic app?
It's like all modules are closely connected. It's not decoupled.
Right. Okay, but monolithic app, we should also understand, is an app which has modules and components. It's not that all the code is written in one line after the other, and it's also structured. It also has various classes, various functions. It could be very well designed code also with various components also, right? But what is more that makes it monolithic, and what is the qualities which is missing in that, which is inhibiting this app to become a microservices app?
Monolithic, it is a single deployable unit.
Right.
Microservices, we can have the multiple deployable units based on the
Correct. Right. So monolith also has a, it's deployed. So yes, there could be dependencies. Again, when it comes to how to deploy a monolith app, it's not that there will be 2 GB of deployable always, and you have to say like a very big piece of deployment which you have to do. It could also be deployed in components, or there may be multiple deployables also, right? So what else is there? So one quality is, yes, it could be that there are big pieces there are not small pieces, and maybe everything has to be deployed together. Although there may be multiple jars, but it cannot be run on system by just having few components running and few components missing. But yes, some monolithic apps are also configurable. You can extend them, you can choose some components, so they have limited flexibility. But yes, this is also a valid point. So both the points are valid, but there is more to it. What else?
Single point of failure.
Okay, what is single point of failure?
For example, any problem in payment service will affect the login.
Yes, yes. They are
This kind of
tightly
issue.
coupled. So
Yeah.
the problem with monolithic system is if one component fails, then the other component may get impacted, right? But yes, there is another aspect of to this. How many database generally a monolithic app has?
One database.
Yeah, so it has a central database, and that becomes also a single point of failure sometimes, because if there are a lot of users connecting to that application, then there may be the performance bottleneck seen with the database, if because if more queries are getting triggered and database is getting slow because of multiple queries, then that may become single point of failure. So single point of failure is a very important term. You should use it in interviews, and you should try to avoid any single point of failure in your design. Because first thing, yeah, Makesh shared this very important point, that single point of failure terminology is a very critical aspect in system design. And any system, whether it's YouTube, Gmail, system tends to go wrong, things tends to go wrong. So if you have a single point of failure, there is always chances that on some important day you will get unlucky and that single point of failure will fail, and your entire system will become unavailable because of it, right? So that's another aspect. So this is important thing, that okay, they have a central database and that may become single point of failure. They may have more components which are single point of failure, because monolithic applications can have many components which can be single point of failure, because if any failure happens, then all the components are together, they will fail. Okay, any other aspect? Do they have services, APIs, RESTful APIs? A monolithic,
APIs can be there, but may not be as services, I guess.
right? So what is difference between a normal service and microservice?
So microservices is it communicate through the REST APIs, but the services is the internal calls. All will be running on the same executable code. So it is a direct function call between the services. Monolithic.
No, this is generally the case, but need not have to be, right? I can write a service in monolithic and use REST in monolithic application also. So, and I can use internal calls in microservices also, right? So protocol do not define whether the service is a service or microservice, right? What defines microservice?
It serves a single, for example, single responsibility kind of thing.
Yes,
For example,
so
account means you'll have only
granularity,
one.
yes,
Yeah,
the
granular.
size scope is what is defining microservices. So the other advantage is, which is very important advantage of a microservice, is if you are working in a product team where microservice architecture is used, if you get onboarded and you have to do some development, right? Do you need to go through the entire architecture of the system? You don't need to go through the entire architecture of the system. You only need to go through the details of the component where you are working. Yeah, your team would be responsible for one microservice. So microservices architecture also enable agile development because teams can focus on individual microservices, and microservices are independent of each other. They are isolated and they can be developed and deployed independently, right? So this is very important point to understand. But in monolith, when you deploy, you have to make sure that the components which are dependent on your service, they are also updating, and you have to test everything together, because there could be side effects, because there is a single database. There are a lot of components which are shared, so if you are making any changes, there is possibility that some of the other behaviors may also get impacted and affected. So you have to ensure that after you are done the development, your application do not introduce new regressions, and new features also work as expected, right? Because the other aspect is building any monolith app is also very difficult, because you have to prepare a very complicated environment for testing, right? So you will have a lot of teams who will be taking care of managing the systems, test systems, and deployment you have to perform, which will also be very complicated, and then you will be developing and testing on these complicated systems, and which will be slow process. But microservices will be something which you can run on your laptop, and you can run in local environment. You can have various other environments for testing and development and integration, and you will be able to do faster development because all the components are lean. So this is another advantage of microservices, right? So let's move to just see what is a monolith architecture. So I have here a monolithic architecture diagram, correct? So you'll have clients. Definitely there could be different kinds of different types of clients in a monolithic app. Then there will be various layers architecture. We sometimes call it one tier architecture. Mainframe systems, they used to be one tier architecture. Then came the client server architecture. Then came the 3-tier architecture and n-tier architecture. So in this example I have shown 3-tier architecture. So you have a presentation layer, you have a business layer, you have a persistence layer, and in each of these layers you have multiple components. So assume if this is e-commerce application, then all the small green boxes, they will be corresponding for presentation layer for say shopping cart, ordering, payment processing. It will have catalog. So all these components will be there, but yes, they will be running in a big environment, and there will be a central database, correct? So most of the applications which were running earlier were a monolith app, and then the teams started breaking these app. So now we'll talk about how do you convert a monolith app to a microservices app, right? Because some of that patterns they talk about how do you convert, right? So anyone wants to share if they have worked in some project where they have a monolith app and they are moving towards microservices app. So is anyone doing such projects? I'll give one example. So the product I worked was SharePoint Online product from Microsoft. So the product, how it started was in 2001, they started a web product which would be installed in the servers within an organization, and these products were on-premise products, right? Later realized that okay, company don't want to spend on-premise products because they have to purchase hardware which is expensive hardware, and it's difficult to scale because if they want to scale, they would need to purchase more hardware, and then they will need to create deployments on the additional hardware, load balance it, and keep doing this, and company sizes keeps growing. So this is kind of a overall process, right? But can monolithic product scale indefinitely? Right? They cannot, because after a certain number of users they reach the upper limit, right? Sometimes you can take care of more scaling by vertical scaling, but it is very difficult to horizontal scale a monolith app. So this is one reason, most important driving factor, why people want to break down big products into microservices product. So what actually happened? In the SharePoint product, they started creating a cloud product because they got the Azure, or they had created the data centers. So getting a data center is also one of the now common practice. All the companies, they have data centers. Data centers are the rooms where they have lot of servers. Servers are placed in racks, and these servers are shared resources. They can store or run multiple applications. So they took this monolith and they deployed it in the data center and provide access to everyone, and then it became a kind of a cloud service, right? So many of the cloud services earlier were like that, right? But the problem with that is, when you get more and more customers, you will start facing performance problems, right? Because you cannot scale. You always have a limit to vertical scaling, because you can get up to, for example, today, if you want a very powerful hardware, the maximum RAM which you can get, any guesses? What could be the maximum RAM in a system which you can get in servers today? Is it 1 terabyte or more? Okay, I got one answer, 1 terabyte. Okay, but yes, what I see or what I have read is up to half terabyte is the RAM, maximum RAM size which you can get, right? I'm not sure about 1 terabyte, but yes, Dave, if you have seen such server, let me know. But yes, whatever I have read, maybe I might be outdated, because this is also a dynamic field. But yes, you can get maximum 1 terabyte or half terabyte of RAM in a server, right? And processors also, you may get maybe 16 processors, 32 processors, but that's the most fastest system which you can get. How to check that what is the maximum device you are available, you can get? You can go to your AWS account. Yeah, AWS, we can assume, is the most advanced and modern cloud environment, and try to create a compute engine, and what is the most powerful compute engine available. So that way you will get to know what is the maximum hardware. Or there could be Google. You can Google onto companies that build servers, right? So what are the companies which are into building servers? Any idea which companies are building servers?
You mean cloud providers?
Servers, yeah, for the cloud. Yeah, servers could be used. You can use it as a desktop computer, but it's not the effective use of. Need not have to be in the cloud. It could be anywhere. Yeah, it's up to you to expose it to the cloud or not. But yes, you can start running software onto that. So yeah, Intel, HP,
Even
right, these are the companies which are into building, IBM, which are into building servers. So you can also search what are the products available from them. So there is always a limit, yeah, and there will always be a limit to the maximum capacity of the most fastest server. And when you have millions of users or billions of users, then definitely the most powerful server will not be sufficient, right? And since you have to deploy everything in one system, and you cannot you cannot horizontally scale them, because the applications are not designed to horizontally scaling, because they were always designed to run on powerful systems. And there will be also no, the cost of these systems will be in millions of dollars, right? So you can't purchase it and keep it in home, because you have to spend that much amount of money, right? So it's in crores in Indian rupees if you want to purchase such servers. But yes, these servers would be purchased by big enterprises. And ideally we would like to run applications on a smaller server, less powerful server, right? Because that will be cheaper. And if something goes wrong, if no, you have purchased these big servers, and there is a flood, and right, entire area is inside water, then you lose all the hardware also, right? If there is power fluctuation or power failure, you may lightning strike, terrorist attack, there are so many things which can go wrong, earthquakes can happen, so you may lose these devices. So it's always advisable to break down your application into multiple components, and you can deploy them into multiple data centers which are physically separated, geographically separated, right? So this way you will be sure that okay, if there is cyclone or any event like earthquake, right, then not everything you will lose, you will have something already running, right? Your application will stay up in that case. So there are various techniques of decomposing a system, because it's not always possible to decompose, because it will require a lot of refactoring. But the patterns which I will be talking about is about decomposing. So the first thing is, you can decompose your application into business capabilities. Business capabilities mean that you can decompose it. For example, product catalog, inventory management, order management, into various functionalities, right? What to include in product management, what to include in inventory management, that's again up to discussion. But yeah, as a developer, you can start discussing it with domain experts and find out various domains, and you can build different modules and create new services out of this. So what you need to do is, you need to refactor the existing code and create smaller services out of it. Lot of effort, right? Entire system, entire Amazon, you cannot do at once, right? If you want to do it, it will be multi-year project. But yeah, you have to take care that there is a lot of complexity involved in breaking down. Sometimes breaking will not be possible, so you keep the functional domain as it is. So you don't say that okay, I'll do payment processing, ordering, invoicing as separate modules, because they may be very tightly coupled. So you can say, I'll have another microservice for finance, I will have another microservice for warehouse, and I have another microservice, say, for master data management. So you can have one microservice which will have the entire domain or multiple capabilities, right? That's not ideal. Smaller is better, because you would like each components to scale, and you would like the development to be as fast as possible, and fast development is only possible if you have simpler and smaller components, right? Because if I have just one service which is for finance, then to develop on these service, I need to know a lot of things. I need to learn, and debugging is also difficult. So it slows down the speed of development. But yes, sometimes even decomposing between functional domains may not be possible, because there could be then other way of decomposing which is based on the business process, right? Then you say, for example, you may have one business process which is if you want to purchase something, you first raise a finance approval request. Once it is approved by finance, then you place an order. Then after the order is placed, then the order will be shipped and then delivered, and then finally you kind of submit the invoice and get the money, financial transactions recorded in the accounts. So this is the entire business process, which is cutting across multiple domains, which is finance, supply chain management, accounts. So sometimes you can partition your apps as per your business processes. There could be many other business processes as well. For example, onboarding a new employee, right, which will involve HR will create a requisition. Then there will be candidates will apply and shortlisted. An interview will happen for candidates, and then finally the offer will be released. An offer will also require approval from finance. It will require approval from various other technical organizations as well. It will then go to HR to create employee records in the employee management system. Then finance will also create record for processing the salary. So that's another business workflow. So business processes could be other way. You can create a microservice which is for hiring, which is for procurement, like that. But yeah, these are again not ideal, but these could be various starting point. And there could be sometimes atomic transactions could be used for transactions, could be another way of partitioning your application. Say for example, if you have internal transfer of an employee, then it may happen you need an HR approval, you need an approval from technical organizations, you need the cost center change and change of records in HR, change of records in finance. Maybe if it's relocation, then lot of other changes. So this is a big transaction. So this is another way of decomposing a system. So this is a pattern of how do you decompose a system, right? So there is one pattern which is strangler pattern. Has anyone heard about strangler pattern? Correct. So assume you are the CTO of Amazon, okay, or CTO of say Microsoft, and I shared you that one application was made cloud application just by deploying the monolith app into a server in the data center and started serving clients. So this way it was a very valuable application for clients, because now it's available on cloud and they don't have to purchase crores of hardware, and they can just subscribe on monthly basis. It's also profitable for Microsoft that you can share the application to as many customers as possible, and no need for Microsoft to provide support and wait for them to install the app in-house and implement it using partners. Microsoft takes care of implementation. So if such applications, very large applications are there, and you have to make it a microservices app, how will you convert it? Someone knows what is the literal meaning of strangler? The hint is from this strangler pattern word. You will use a strangler pattern to break a microservice to to break a monolith to microservice, right? Now I'll give you another visual cue, right? So the approach you will take is, you will have right now this, right? You'll start creating new features, small services, right? And you'll start breaking it. And then finally you will reach this stage where you will have microservices architecture. Correct? Any queries on that? So strangler stands for vine, or it's the climber, or is. So what actually happens, assume this is the tree is your monolith. So what you will do, you will get, so one climber will have one branch going from bottom. Then it will start strangling branch by branch, and then finally it will be all around the tree. So this is how the approach for breaking the monolith to microservices is prescribed with the strangler pattern. Anyone wants to put some more inputs, thoughts on this? So now we covered our pattern, which is a strangler pattern. We covered what is my monolithic architecture. We covered what is microservices architecture. Next thing is, we already discussed this, that we want to have loose coupling of services. And the loose coupling is possible if you have different servers for these services. You may have same servers also, but they should be isolated. You should have the flexibility of starting, deploying, restarting, updating cache in each of these services separately. Because in the monolith application, when you have a new release, you say, okay, this is my 1.0, then next, after 6 months or 1 year, you will say this is next version 2.0, and so on. But in microservices, you don't say I'm using Google 5.0 or I'm using Gmail 5.0 or 6.0. There's no such version. Why? Reason is that they are built of multiple microservices, and they may be updating it very frequently, right? So do you know how often are microservices updated? A microservice based application could be updated every month, right? Could be updated every week, could be updated every day also, right? So many companies, they are updating things every day, and they are also updating applications hourly and in minutes. So the big organizations like Google, Amazon, Microsoft, Facebook, they have the capability to deploy changes in few hours, right? Because deployment involves lot of steps. You have to build the application, you have to compile the code, build, package all the dependencies, create the installers, and then apply it to various systems, right? Takes a lot of time. But if you are able to do it fast, then you can react to the market needs very fast. In case things go wrong, you can also recover from it very fast by quickly delivering a patch, right? So that's another important thing, is your cadence. That's called deployment cadence. Very important parameter to be taken care of. So the next pattern is database per microservice. So this is simple. You have different microservices. Now I have gone through the changes, but no, after microservices are broken, I have to decide what kind of databases to use, right? So first pattern what I will apply is I'll use separate databases for each of the microservices. So you may have web application, you may have mobile application, and each of them connected to separate database. What's the advantage of that? One is isolation. You will be able to scale also higher, because if you have a single database, you may be able to take, say, a database can take up to 5,000 write connections and maybe 10,000 read connections, this per second. So this is the limit you have for the database. But if you have multiple microservices, then you have higher scale, right? Because you'll not be hitting all the time a single database. Your database queries will be partitioned into whatever microservices are being used. So now there are so many different types of databases as well, right? So in the previous monolithic application architecture, since you have single database, you can only choose one database. Either you go with MongoDB, or you go with Oracle, or you go with MySQL, you go with say whatever database technology, Neo4j, Cassandra, or you go for Postgres. But yes, once you have finalized a database technology, right, there are now hundreds of databases in market, InfluxDB. But yes, you will have to use only one because you have only single database. But in this case, in this pattern, microservice per database, I can choose for finance relational database. I can choose MongoDB for my product catalog, and so on. I can choose a variety of databases, right? But yes, you should also take care that access of anything is bad. If I choose hundreds of database technology, it will be very hard for me to manage the application, and my complexity of development will increase. I have to hire MongoDB expert, I have to hire maybe Oracle expert, MySQL expert, so many different kinds of interfaces and API my developers need to know, and that will be a problem. So, but yes, some variety is good, because that way I can use the best thing of my choice. But yes, I should have few different choices, not many different choices, right? So this is the diagram for one database per microservice pattern. Clear? Simple. Up till now we are covering very simple things, but thing may start getting complicated as we go further in the patterns, because I've arranged these patterns from simple to harder ones, because that's easy to understand, and know why the books which are already there, or blogs or articles which are already there, are difficult to understand, because the way they are presented is not in the order of complexity, right? So yes, this is again another architecture diagram for microservices architecture, right? You have clients, you have an identity provider, which could be, for example, OAuth, Google, Facebook. So when someone logs into an application, he says what identity provider you want to use, whether it's Google or it's Facebook or LinkedIn. You have so many identity providers. You may have corporate identity providers also, like my employee Active Directory or Oracle Active Directory, which is a set of all identities of employees in an organization. Then there is another pattern which is API gateway pattern, which we'll be covering next. And then there are various services, and these services may be storing some data, or they may be calling other remote services as well. Like Amazon, when you order an item, you get to pay via UPI, and when you say pay via UPI, you will be calling a payment processing microservice, right? Okay, so just ignore, we'll cover what is API gateway. But then the next pattern is CQRS pattern. Yeah. Anyone knows about this pattern? And what it is? I am sharing the diagram. Can anyone understand the diagram and tell me what this pattern means? So this pattern is called, no one wants to take this attempt. This is called command query responsibility segregation. So here they say, okay, you use one database for write, one database for read. Correct? So is it possible that, for example, no, I have a products, I have an e-commerce application with lot of products. I'm storing all the catalog information. When I'm writing it to Oracle database, but while reading, I read it from, say, MongoDB. Yeah. In some of the finance applications, they may be having this thing, like they're writing to relational database, say Oracle, but reading from some other database which is MongoDB. Maybe they have data format which is JSON data format, which is more preferred, and the other way, while writing they want to ensure that transaction is there and you have atomicity and consistency, right? But yes, you can sync them together. Need not have to use different kinds of database. You can use different database instances also. For example, master slave architecture also. You read from other database, but you write to another master database. So it could be same architecture database, or it could be a different database altogether, right? But you need to ensure that both are in sync, because otherwise you'll not get the updated information. You'll read some wrong data, but you will write something different and read something different, and that is not the right behavior for any application. So this is about the CQRS pattern. Any queries on that?
Can you tell some examples where the CQRS pattern will be used?
Okay, sure.
And also, Tarun, one question. I mean, is it only for read-heavy applications we are segregating?
Yeah, right. It could be anything. Write heavy, read heavy. Yes, this is again very good point. So this you will use when either you have a read heavy or write heavy, right? If you have similar characteristics of reading and writing, then why would you use multiple databases, right? So here the main goal is you have different kind of read and write characteristics. It could be either. It could be write heavy or read heavy, because your insert, update, delete commands will go to write database. Select queries will go to read database, right? So I'll give an example. Assume you have all of your application dumping some logs, right? You may be writing the log files to some database which is a document database, say MongoDB, right? Then once the logs are written, there may be some scanners, some other applications. Yeah, Google again is a classic example. You have data which is there in so many websites, but when the Google search run, it runs on Google indexes also only, right? So they may be using some database for Google. So when a new site comes, they put data in some other place, but then finally it reaches some other database and then you read from there. So coming back to the example that you may have some log application which is writing in some unstructured database, but then you want to create matrices out of it. So you are syncing whatever is read and you are showing charts, right? Reading is you are viewing some graphs and real-time charts that may be coming from a different source, right? So this is an example of CQRS pattern, right? You may be writing to a different source database and reading from another database. Yeah, master-slave architecture also, if you consider, you don't have to have masters exactly of the same database, right? I may have master as my Postgres, slave as my Oracle database, because what I need to do is I need to replicate, right? And replication is if both of the database are talking SQL, or both of them can import CSV files, or there is some standardization, I can replicate across them, right? So this is CQRS pattern. Hope now you understand it and you also understand it, the benefits. Now this also opens up your mind to more options while designing or answering any system design questions, right? So these patterns are really very helpful.
Yeah. Taran, one question about Event Hub. Is it like what kind of? Is it like a middleware which will convert?
Event bus, yeah.
Yeah, what is that exactly? Like, is it like a middleware which will convert?
Is a queue, yeah. It's a middleware. It's a queue, message queue. So whenever there are writes happening, the updates are written to the event bus, and these updates are consumed by the read database. Yeah.
Okay.
Correct. So this is about the event bus, and you don't have to go to the implementation detail in system design. It could be maybe an intermediate server, because you can temporarily store some information, because the only problem is if there are too many updates you are firing up to read database, and you are firing as and when it's happening, then there will be overload of write database, because not only it has to write the data, it also has to sync it to read database, right? And if read database is also busy, it may not be able to consume the messages, new updates at the same pace as it's getting written. So you need a buffer, and buffer could be a system or it could be a queue. It could be a database also, and it has a sync which is going on. So this is about the CQRS pattern. Any other question? Okay. Correct. So yeah, it could be simple synchronization. So next, coming to the API gateway pattern, right? Exposing a web service is not easy thing, because when you expose a web service, you have to ensure there is security, because hackers will be looking forward to hack your system, right? Because anytime you will release a new product and you become a unicorn, or you get some marketing, right? You got funding and all, there will be your competitors, lot of people with bad intention. They will start to overload your application, because that's a problem with the cloud service, that it's exposed to public, and public could be bad and good, and they may start running attacks on your services, which could be denial of service attack, which is the common attack. It's simple attack because you just have to send multiple requests to bring down your service, right? So exposing, you'll need load balancers to balance the load also. You'll need lot of other things, like you might want to charge your customers based on the API usage. So there will be lot of things. Yeah, I have called them cross-cutting concerns. This is one word which you can use. Cross-cutting concerns can be taken care by the API gateway. So which could be connecting to identity provider for authorization and authentication. It could be discovering which IP address belongs to which microservice, because that data also you need to know to call all the microservices. It could be caching, because you don't want all the requests to hit the server, because if you have something already cached, better serve from cache. Rate limiting, throttling, load balancing, logging, tracing, correlation ID you would have seen used in distributed tracing, and putting headers, putting query strings, doing some transformation of data, whitelisting, blacklisting of IP addresses. All these cross-cutting concerns are taken care by API gateway. So your individual components need to focus only on the business logic. They don't need to focus on anything which is authentication, authorization, because if you have to implement authentication for all the services, it is too much of effort, and it will be redundant effort also. Anything changes in authorization, you have to change all the microservices. So this is the advantage of API gateway, and API gateway is one of now very important business in software industry. Lot of companies are coming up with API gateways, because as more and more companies are moving for microservices architecture, API gateways are becoming very important. Right. So gateway, API gateway or gateway routing, they are similar, very similar. Correct. So I think, any doubts on this API gateway pattern? API gateway has a load balancer. It has modules which can prevent denial of service attack. It can verify your request by looking into API key. Now you would have known there are API keys used, because they are used in tracking whether the user request is within a limit. If you are over utilizing any service, they will rate limit you, or they will disconnect you from the service if you have exceeded your quota. Circuit breaker is another pattern. We'll cover that also. Quality of service is just ensuring that in case when the request was made, a server goes down, what will happen in that case? Your request will not get served, but that's a bad experience. What if we cache your request and send it to the server when the server comes up and give you response, right? So this is another way of ensuring quality of service for your customers by having retries. Or if some error comes, why not we try to resolve it at our end and retry. So this is about API gateway. So API gateway is again, having a lot of features. You can read. I can, that can become a separate session if I have to go to API gateway in detail. But you have to just understand most important function is the routing, and API gateway also helps your clients to just have one endpoint, right? Because if I am a developer and I want to develop on Amazon platform, and you give me, okay, for customer services you call this endpoint, for shopping cart APIs you call this endpoint, for all these modules you call different endpoints, then it will be very difficult for me to choose and remember which API endpoint I should call. So it simplifies development experience as well. Aggregation pattern, as the name suggests, is a pattern where I can simplify my request, right? So with gateway, there is another possibility, which is service aggregation, correct? So assume I want to add an item to a shopping cart, right? So assume my API is add item to shopping cart. But when I add an item, I need to also see that what is the price of that item. So I may be required to call another service which I call get price for an item. But yes, again it becomes complicated. For just doing one activity, I have to call two services. So I can simplify it by just exposing another service, which is add shopping cart item. What it does is it adds to the shopping cart the item, and it also finds out the price and adds the price to the shopping cart, because that is also important for ordering an item, right? And it can also apply discount in case any discount is going on. So there could be multiple services which are called in background, but what is exposed is an aggregated service, right? So this way I can simplify the request for my clients. So this is service aggregation pattern, right? So this is also very helpful pattern, and I understand or I hope you all are appreciating the pattern and its usefulness, correct? Any queries on this pattern? I can move further otherwise. This is a little bit now, not everything is logical. I need to take a branch here. There's a slightly different kind of pattern, but yeah, it's also related pattern, which is called backend for front-end pattern, right? So backend for front-end pattern means you have different backends for different kinds of front-end. So you have a desktop application, so you have a different backend for desktop application. If you have a mobile application, you have a different backend for mobile application, right? So you can create different backends for different kinds of applications. You might have seen this in many places, right? So what's the advantage of this? There may be different kinds of requirements for the patterns, for different kinds of clients. For example, when you are viewing an item in a mobile, you may not want to show all the details. You may only want to show the 5 properties of an item. But when someone is viewing it on desktop, you may want to show 100 fields related to a product. So you have a different API requirement for mobile application and for web application. Maybe someone is searching on web in desktop. He may want to see 100 items for his search results. but in mobile maybe someone is only looking for 10 items for the search result, right? So there is almost the data could be similar, but there are slight differences. There will be not totally too much difference in the behavior, but there will be considerable difference, so that they can use different backends, and internally maybe they are calling the same service, but there is another layer which is a gateway layer, which can see what is the client and can expect some different inputs, right? It can modify some inputs and it can update some inputs and call the services with different set of parameters. So this is about backend for front-end pattern. Advantage of this is, if one backend is down, maybe your only mobile app is down, right? It again avoids single point of failure, which we were getting in API gateway. So API gateway is helpful in microservices, but the disadvantage is it's also bringing single point of failure. So here you are avoiding that also. Right? I move on to different pattern, because now let's see how many I've covered. Yeah, I think I have 4 more patterns to cover. So hardly it will take 10-15 minutes more. So this pattern is covered, circuit breaker pattern. Anyone knows it? What's a circuit breaker pattern? I'll give a same example, that I'm adding a item to shopping cart. But I also know that my pricing service is down currently, right? Or is not performing well. So if I keep sending more and more requests, what I will see is failure, right? My shopping cart item could not be added because the price information is not available. So what will happen is, I'll make a call, and then this call will be broken down into multiple calls. One call will try to add an item to the shopping cart, other one will try to retrieve the price, and price service is down, so it will fail, and then the failure will also happen in other service, and there will be cascading effects of these failures. But why not I fail it in first step itself? So circuit breaker pattern allows you to break the circuit before. If something is down, it does not allow to call further services, right? Or another example is, assume ticket booking in IRCTC is down, right? So they don't allow you to log in, or they don't allow you to search, or they don't show you that airline or flight ticket which you will not be able to book, right? So this is a better user experience, because you don't waste time in exploring things and then later realizing it is down. I better tell you in advance that since no pricing is down, so I'll not be able to book your ticket, so you please search later, because no, today you will search, but yeah, by the time you will book, prices may change or seat availability may change, so no benefit of searching now. So I apply a circuit breaker. So circuit breaker pattern involves a health check component, which will be monitoring the health of different services which are required, and then it will see that if the threshold is reached, it will have a logic when to break the circuit. And although my ticket booking service was up, but still I circuit break and make it down purposefully, because I know if something is down, it may lead to more errors in my system, and there could be more problems in my system because of such failures, right? So this is the circuit breaker pattern. Service aggregator we already covered. Service registry pattern. You would have heard of service registry. It is catalog of APIs, and it is a database where you have list of all the endpoints. So is used by gateway. When you call API gateway, it does not have all the endpoints information hard-coded. It will have a service registry. Service registry stores the list of services and their endpoints. It refers it and then routes the call to the appropriate endpoint, which is based on your request. Correct. Clear. Service registry is same service registry which is available in various applications or architectures. When you have explored architectures of various systems, you would have seen such service registry. But yes, you should think in these terms and you should try to share this and have this in your design, in your system design. Next is event sourcing pattern. This is a very interesting pattern. And if I ask you question like design Google Doc, okay, I'm not interested in how the documents are stored. I'm more interested in collaboration between different users. How will you take care of that? Right? So, or there could be many other scenarios as well. So this is how it is done. It's done using, you can just mention to the interviewer that I'll use event sourcing pattern, right? So assume you are given a problem in an interview, design Google Docs. An interviewer says you design file sharing, you design upload of files, you design how will you update the files, you design sync, you design how people will collaborate, right? Now you did good thing in you did well in design of all these modules, but you have only 5 minutes left and you have to share how the collaboration will happen in Google Docs. So you can simply say I will use event sourcing pattern. That's it. The interviewer will understand that you are talking about this diagram. So you don't have to draw this, and this may take 10-15 minutes to draw at least, right? So this is an advantage of knowing these patterns. Same you can do for other, you can tell API gateway, or I will use service registry for specific problems, or I will use service aggregator pattern, or I will use different front end for back end patterns. So it's very helpful to know these terms. Now coming to this pattern is, you have a UI, then you perform various operations on the data, which could be document. So you added some title, you added some paragraph, you added some formatting, you deleted some paragraph. So you should not keep updating each and every operation in the database, because that will have too much of database calls, right? So if I keep updating my document, I will be playing around, and so many database writes are happening, right? Which will be problem, because if you have millions of users and every second they are changing some text or updating some format, it will be too much. So to overcome this, what you do is, do not write directly to the database, write to a event store, preserve set of operations which you have performed, and once this event store is ready, you can at a different interval, after waiting some time or at some based on some schedule, you can transfer these operations to the database, right? So this way you not only are able to store the data and reduce the load on the server, you are also able to have replay of the event possible, right? So if you want to say I want to do replay or I want to undo to certain point, that is possible with this pattern. So this was the last pattern, I believe. So they have also, so here there is an example of shopping cart also. You can do with the shopping cart also, and you can undo whatever you did in the shopping cart, right? So same thing is explained. Okay, there is one more pattern which is materialized view pattern. Yeah, this is the last one. Anyone knows what is materialized view? Okay, these are all fundamental things you should know, and I'm happy that I'm able to cover all these, and these all things are new to you all. So this session is getting very useful for you, because yeah, materialized view is a very important pattern. I will give an example. Assume you have to design Facebook news feed, and when you have Facebook news feed, you want feeds from all the friends, also feeds from maybe all the groups. So you have to reach out to the recent updates from your friends, and you have to reach out from recent updates from your groups. But these two tables are different. So what you will end up is, you will end up running two different queries, and it will be an expensive operation. Yeah, because no, your friend's database updates will contain the updates for his entire lifetime, and it will be a huge set of friends, so it will be very slow in processing. For groups, same thing applies. But what you can do is, you can create a temporary view, a table, which contains the last 1 month update from your friend, and also it has a join of all the last 1 month update from, or 1 day update or 1 week update, depending on what is the requirement. You will have a temporary table or a view which is also taking some memory in your database, and this is fast to query. So that's a materialized view, and it also gets updated, right? If you want to refresh it, you can refresh it also, but it's like kind of a table, small table, which is made up of relevant data for your transaction. So this way you can improve the performance of your API, right? So coming back to our example of shopping cart, you have pricing table and your product table, but these are two different tables, and these are tables of all the products and all the prices. What you can do is, you can create a materialized view which contains all your shopping carts, right? So this way you can kind of have a table which is created from these two base tables, but it is kind of a cache, and this helps you to retrieve the items very fast. So this is materialized view pattern. Clear? So this is also very useful in applications like when you are designing news feeds or various use cases. Very common pattern and useful pattern. So this is all about 11 microservices patterns. Correct? So we covered all these patterns. Any final questions, queries, inputs, feedbacks? None?
No, no, Tarun. Great. I think we should start using it.
Yes.
Thanks, Tarun. This really good session for us actually. A lot of things which I was not aware and like.
Yes, because I saw that no one is covering this in any system design preparation courses. This is very important. And yes, so this I have created to help you guys to do better in the system design, because from my experience with system design, this is something mostly the interviewers are ignoring. So if you know this and use it, you will stand out in the interviews, yeah, from other candidates, definitely, because very few people use it or know about it. Yeah. And when you know it, you can also use it to improve your speed of answering the question what is asked in the system design interview, and also it will help you to improve your solution and do it very fast, because if someone knows these, any question, system design question, he'll be able to solve in 15 to 20 minutes, and he'll have time for deep dive into these topics, so you can then go in depth with but yes, with high level design you will be finished in 15 minutes if you know it and use it properly. And then you can also go deep dive into database design, API design, various other REST API design things, which is also very much required. So I would say knowing this is a must for everyone who is preparing system design interview.
Tarun, one question. I mean,
Yeah.
only the strangler pattern, that is only pattern used in migration, like breaking the monolithic to microservice. Rest everything is used in kind of new design. Correct?
Right. So patterns can be applied in different situations, but strangler pattern is a pattern for breaking down the microservices. The rest of the patterns were patterns which were more into designing system, using a design system, right? So basically, after you apply the strangler pattern, right? So it's about breaking down a big service to a smaller service. Once you start designing these smaller service, you can use appropriate patterns, remaining patterns, right? So always you apply multiple patterns together to form a solution.
Okay, thanks.
Right, but there could be more patterns also which I might have missed, right? So for example, there is a sidecar pattern also. Do this as a homework. Read about sidecar pattern. What is sidecar? Sidecar is spelled like, in sidecar is in Sholay there is a song, no, Ye Dosti, so there is a sidecar, right? Scooters have this sidecar, something. So that's also this is the name of pattern, correct? So do a research and tell me, come up with, we can discuss this in the WhatsApp channel about what is sidecar pattern. So there may be more patterns also which I have not covered, because can't cover everything in one session, and I covered the most important patterns. But yes, if some other patterns you find it useful, let me know and share it with others. Right, and but yes, it could be a continuous activity. You will encounter new patterns. You will also learn more about existing patterns or some variations of the patterns. More you know, better it is, right? More patterns you know, but some you should know at least. So these are, I would say, 80 to 90% of patterns which you should know. Maybe I have missed 5-10% of patterns that are also useful, that you can explore on your own, but this is a good starting point for all of you. Great. Anything else?
Thank
Okay.
you, Karan. That is very nice session.
Okay, great. Nice to know about your inputs, and glad to see you all found this helpful. Okay, see you. We'll meet up
Thanks.
next time.
Thank you,
Karan,
Karan.
can you able to share this document if it is in finished state?
Okay. The document. I'll
Yeah.
share the recording, and document. I will take some time because this is a document which contains previous content of the previous sessions as well, right? So
Yeah.
I should be completing this sooner. I've made it as a book now. Right?
Okay.
All my
Okay.
3-4 sessions, I've made it as a book, and some things I am rephrasing also as like a conversation way. So some of the topics I'm describing in interviewer candidate conversation. So yes, this is, I'm preparing the document for you all people only, and will share this because you see it's a 100-page document. I'm just reviewing it, and I will share it in few weeks from now.
Sure, Taran. Yeah. Thank you.
So once I have it in good shape, I'll share you so that it can be used by you. And right, it will be very soon. It will be, I think, in few weeks I'll be sharing it. But yes, till now, watch the recordings because these no, you can skip to the appropriate section. I'll try to put the bookmarks in the recording also, so that you can very easily navigate and see these diagrams. But then once it's in good shape, I'll share this document also. Perfect. Okay, have a nice Sunday. See you.
Thanks, sir.
Thanks.
Thank you.
Bye.
Thank you. Bye.